I'm from Ingate, and question is, what is a zip trunking session border controller vendor doing in this space? We're used to connecting PBXs, but normally, unfortunately, we are connecting PBXs, and even if they are fine unified communication machines for the enterprise, we're still connecting them to the old plain telephone network, the POTS network, even if it's run over IP. But WebRTC really makes it possible for us to give it some benefits of global real-time communication in a modern form. And what we do, we provide, for example, if you do the click-to-call on a company website, you can get into the PBX, unified communication infrastructure inside the company. And you can also pass a link and get into a zip phone or a zip client or whatever being forwarded and so on. You can also use a web browser as your soft client for the PBX, both locally and remotely. But that's not what we're going to show today, because we're doing another thing. That is on our display table. And the other thing we're doing is, we call it Q-turn. You know what a turn server is? That's a part of how WebRTC traverses firewalls. What's happening here, it's an infrastructure thing. Real-time communication has been over an island form of overlay network of what the carriers think is a more qualified network than the internet, but we're moving the traffic over to the internet now. WebRTC doesn't have any option of going on a separate network. But what happens with the quality? Well, the way we traverse firewalls, and we're almost always behind a NAT firewall, is something called ICE, which uses stun and turn. And if we want to get control over the media streams to do quality of service that we otherwise can do in a firewall, we can prioritize and traffic shape and make them stay within the pipe, and we can even set quality bits to be transferred over the pipe. We can put the turn server and the stun server inside the firewall and get control of these things. And that is what I'm going to show today. And we can actually, by introducing Q-turn, we can do prioritization and traffic shaping for real-time traffic. Just standard WebRTC, instead of fooling itself through a firewall, through outside service, what it's doing, we have a new view on it. It says, knock, knock, I want to get a real-time communication pipe. And the firewall interprets that, because he is the actual stun and turn server. So then he sets up this in a control form and gives access and prioritizes it. It's even possible to do authentication, because that's part of the stun and turn server. Who is using these resources? And you can do accounting. You can measure how much of the resources are used. And why is this important? Well, WebRTC, I mean, it has the option or the potential to take us from what we've seen so far is really 3.5 kilohertz voice communication only for 50 years. And there's been no development, really. Now we suddenly, in one step, moves up to the potential 20 kilohertz and HD quality video. That's a giant step. At the same time as we're moving it over to best effort internet. And we can't just rely on that UDP passes better than TCP. And it's not all about bandwidth. The bandwidth is always full, not always, but mostly, of data traffic. You surf, you email, and it always fills the pipe intermediately. And carriers, they are concerned about these things, and they've been building triple play networks with special networks for VoIP for years. But unfortunately, they don't give us telepresence quality they put the things out to an old telephone in the end. So we're back there, and with WebRTC going over the internet, we have the widest bandwidth over the internet. We just need to prioritize and use it also for real-time data. It's about sharing the bandwidth that's already available. So how we do this is what I did not bring to this podium, because the demo setup is a bit complicated. So this is what I want to show. And it's really firewalls, which is our session border controllers extended with this Qturn functionality. And 2 web browsers connecting to each other, and we simulate this data-crowded network with a 10 megabit hub. And you can all see this up on table 27. And then we, simultaneously as we do this WebRTC call, we do push a lot of TCP traffic through the same. And where the pipe is most narrow, of course, they have to share the bandwidth. And to do this, since I can't demo it, I pre-recorded some videos here. And to make it really realistic, they're quite ugly.
Now we have new quality of service on, and no extra traffic generated to make disturbances. Let's call Philippe.
Doing this, and this is our demo application. I'm calling the other end over this pipe.
Hey Philippe, hello. Can you wave it to me, slowly?
Let's start
and
waving
give me a
in
smile.
Swedish.
Okay, that looks fine. I'll turn on some extra TCP traffic here and fill the pipe.
There's no really problem now with the transfer here. But then we turn on,
see if the traffic is coming in here.
The traffic generator. So we started pushing this TCP traffic, and it always fills the pipe.
I see your hand.
We're up to
shaking.
10 meg pipe
Continue waving.
Transferred, and you can see his hand is going a little shaky now.
That is nice.
Oh, if you saw that, I turned it on. And now let's see the same thing with, you see these peaks here in TCP traffic. Now we have this small problem with, can Microsoft come and help me? This happens every time after I play an AVI file, but PowerPoint still works. So let's see the same thing with Qturn turned on.
This time I switch on the Qturn quality of service and the traffic generator with extra disturbances and call Philippe again.
So this is from the last call. So we make the call again. And this time...
Hej Philippe. Vinka lite till mig nu då.
We still run the disturbances, but we regulate.
Continue waving.
It's just the traffic shaping.
And we can see it stabilizes
the bandwidth
the
under this
bandwidth
10
to
megabits,
below
the total
what we actually have available.
Shutting down the TCP
small
traffic.
bandwidth.
And we have the
much smaller bandwidth for the actual video is coming through fine.
Slowly starting. That's something smart that Google has put in here, that it doesn't shut off high resolution from the beginning. So if you saw while I was talking, the hand wasn't shaking anymore. So typical realistic demonstration with an ugly camera cutting the demonstration setup or filming it. So do I have any time left? No one is protesting. Why is this important? Well, it's not only for the enterprise or your personal use. It actually can be used for carrier broadband delivery. Why don't you deliver at the delivery point the CPE you're providing at home or school or even behind the cell tower mast with Qturn? That means you don't have to deliver only best effort data. You can actually deliver quality, prioritized pipe. You can get the sell a WebRTC ready access. And OTT, I think that's the mobile's names for internet, but that's today's only best effort data, do whatever you want. Now you can actually also give quality to OTT. You can get telepresence quality in your pocket. And the place to put that in is really, there is something called DPI, Deep Packet Inspection stuff. Okay, I'm running down quite nicely. In the mobile world, it's extremely complicated, but if you put Qturn in there, you have a possibility to deliver real-time data and best effort data. Okay, thank you.